Welcome to the session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discuss one of the laboratory experiment in engineering chemistry, that is estimation of copper by colorimetry. Here, we are going to know or measure the concentration, the unknown concentration of copper comparing the known concentration standards of water, concentration of copper using colorimetric method. So, the brief outline of this experiment is aim and the apparatus which we are using, and what are the chemicals required to do the reaction or the experiment, and principle or theory involved in the estimation of this copper concentration, and the experimental setup or the instrument which we are using for the estimation of copper, and what are the procedures we are following for this experiment, and what are the observation tables or the readings from the instrument, and the calculation part, and the graph followed by result. So, our aim is to estimate the amount of copper in the given solution using colorimetry. So, here the apparatus which required to carry out this experiment are colorimeter and standard flask and test tubes, measuring jar and cuvettes. So, the chemicals required in this experiment is copper sulfate and hydrosulfuric acid. And this is the colorimeter, digital colorimeter. So, colorimetric method depends on, generally it involves the principle Beer's law. So, when light is passed through a solution, it absorbs some light. So, it is color solution. It absorbs some light and it gives transmitted light. It absorbs some light and the light passed from this solution will have less intensity or less light, because due to the absorbance of the compounds or chemicals present in the water sample. Here generally this is the measurement of quantity of light absorbed by a color solution due to the Beer's. This is according to the Beer's law. Here log I naught by IT equal to epsilon into C. What is I naught and IT? I naught is intensity of incident light. So IT is intensity of transmitted light, which fall on the water sample is called I naught, and which is came out from the water sample is IT. So here E is the epsilon. Epsilon is the molar absorption coefficient, and C is the concentration of the solution, and L is the path length or thickness of the medium. So we can calculate using this formula. It is according to the Beer-Lambert's law, and this can be represented equal to A is nothing but the absorbance, is equal to epsilon into concentration of the solution into length of the path length or thickness of the medium. And optical density, it can be expressed in terms of OD is optical density equal to epsilon into concentration of the solution into path length or thickness of the medium. So, it involves a step-by-step procedure. So, first take 11 clean tubes and all the test tubes are labeled as from A to K. So the 11 tubes has to be labeled with A, B, C, D, E, F, G, H, I, J, K. So, in this manner from A to K, 11 test tubes has to be labeled. Now, the standard copper sulfate solution or mother solution of 0.5 molar concentration of solution of copper sulfate has to be prepared. So, once suppose this is the copper sulfate solution, 0.5 molar. So, this is the mother solution, 0.5 molar of copper sulfate, CuSO4. Now, we have to dilute and prepare A to K solutions using this mother solution. So this is the copper sulfate solution. Then it mixed with distilled water and serial dilution has to be done. Here, suppose from this we have to take 1 ml, here 1 ml, plus here 2 ml, here 3 ml, here 4 ml, here 5 ml, here 6 ml, and here 7 ml. 8 ml of copper sulfate, 9 ml of copper sulfate we have to take in this way. So, if we took 1 ml, we have to add remaining one. It has to be, everything will be up to 10. All the solution has to be prepared for 10 ml. So, if it is 1 ml of copper sulfate has to be mixed with 9 ml. So, the total volume is 10. So, if it is 2 ml, we have to add 8 ml. So, the total volume here is also 10. Same way, if it is 3, we have to add 7 ml of distilled water. So, if it is 4, we have to add 6 ml of distilled water. If it is 5, we have to add 5 ml of distilled water. If it is 6, we have to add 4 ml of distilled water. If the copper sulfate solution is 7, we have to add the remaining 3 ml of water. If here 8 ml is copper sulfate, we have to add 2 ml of distilled water. So, if it is 9 ml, we have to add 1 ml of distilled water. Okay. So, in this way, from A to K, we have to prepare 11 test tubes. So, this is pictorial representation where 0, here we are not adding copper sulfate. So, 0 ml of copper sulfate followed by 1, 2, 3, 4 and 5 ml and 6 ml here and 7 ml, 8 ml and 9 ml and 10 ml. Now, once copper sulfate solution is added, then we start make-upping with distilled water. This is distilled water. Now, we have to make up the up to 10 ml. Again, we have to add 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Here only copper sulfate solution. So, the whole thing is happens in 5 steps. One is standard preparation, like mother solution. As we discussed, mother solution has to be prepared. 0.5 molar copper sulfate. From this, from this we have to dilute from A to K. From this we have to dilute A to K. So, next thing is instrument stabilization. In chemistry experiments, the main thing is before doing any experiment, any instrument has to be stabilized for particular time. Suppose if we are going to do this colorimetry, we have to stabilize with blank and we have to stabilize the filters before its uses and before its analysis in the laboratory. So, for the instrument, the filter and the absorbance has to be 0 and the transmittance should be 100. So, we have to set the instrument with absorbance 0 by inserting the blank water and the transmittance should be 100. And the third step here, first step is preparation of standards and diluted standards. Second step is instrument stabilization and third step is measurement of absorbance. So, here we are going to measure the absorbance using the instrument. First, the absorbance of the blank. So, blank is nothing but the distilled water. 10 standards of solutions which we prepared by using 1 ml of copper sulfate and 9 ml of water. Next, B is 2 ml of copper sulfate and 8 ml of water. C is 3 ml of copper sulfate and 7 ml of distilled water. Like this way, from A to K, 10 standards are prepared and one unknown solution, which we don't know the concentration. So, which we don't know the concentration, but the color of the solution is blue. We have to find out the concentration of copper present in that unknown solution. Then, by taking the readings of the standards, we have to plot a graph. A graph is plotted with absorbance and concentration. So, if it is 0.5 0.01, 0.02, somewhere if we are getting the absorbance reading like this, we have to plot a graph by using these readings. Then now the unknown concentration of the solution is somewhere here. We have to correlate this and we have to find the unknown concentration of the copper solution through the graph. Then the measurement of the absorbance with calorimeter is generally a two-step process. The blank solution consists of all reagents and developing color. Generally, if some stabilizing agents we are using, like sulfuric acid, on preparation of copper sulfate solution, for stabilization, some amount of sulfuric acid is added. So the blank here nothing but only the mixture of sulfuric acid and water, but no reagent or no complex material, like no copper material is added inside the blank solution. So the measurement with colorimetry can be done by first adjust. The first thing we have to do is absorbance to 0 and the transmittance to 100%. So the light which is passing 100% transmittance means the light which is passing from the source to the detector, it should be 100%. So that is the stabilization point in calorimeter. So now replace the blank solution, take out this blank solution and keep the standard solution in the cuvette holder. Here for calorimetry we will use cuvettes. These are the small test tube like apparatus where the solution was filled 3/4 and inserted inside this calorimeter. So once the reading was took, we have to replace the solution with the another standard and we have to take the reading for the we have to wait for constant value, then we have to take the reading, then throw this solution and then take the other solution, like if A completed, move on to the B, next to the C, like this, C to E, then up to K. We have to take the readings from A to K. After that, we have to take the reading of the unknown solution in the same way. So a table is plotted with the from A to K and the absorbance with from A to K. Absorbance has to be noted in the respective column. Then the measurement of absorbance of unknown solution. So it measures the absorbance for unknown solution at the same filter using the graph using absorbance and it determines the unknown solution. Here if we see the the theory which we have seen is a pictorial representation of all the theory which we have came through. Now this is the visible light. So it is passed, these are the filters. So it is passed through the diffractor or gratings or filters, then it enters into the colored solution. This is like our copper sulfate solution. Then here the photocell will be there. So when the light passes, the solution present in the copper sulfate solution absorbs ions and gives the light. Based on the absorbance, the absorption of the light, we will get the absorbance in the calorimeter. So based on the absorbance we got, we are going to plot a graph with this absorbance in the left side. Here absorbance, x-axis and y-axis concentration we are going to plot and correlate. So this is the tabular column where 0 plus 10 ml means here we are not adding the copper. Next B is 1 plus 9 ml, C is 2 ml of copper sulfate plus 8 ml of water, and D is 3 ml of copper sulfate and 7 ml of water. So by adding this concentration, the concentration and the molarity we are getting for this solution is 0.05 m, 0.10, 0.15 m, 0.2 m, 0.25 m and 0.35 m, 40 m and 0.45 m. For J it was 0.45 m and K it is 0.50 m. Then the next value should be the unknown. So this concentration we don't know. Based on this absorbance, we are plotting from the graph. So the weight of copper present in the given solution is here. From the absorbance we have to calculate the molecular weight of copper sulfate into volume divided by the we will get from the graph, and divided by 1000 gives us the concentration of copper present in the solution of unknown solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.